Hi everyone, I'm Miss Levy and I am here to review Chapter 1 and this will be a series of a couple of videos. So please go ahead and pause this video to make sure that you have your notebook and that you have these documents all accessible to you. So please pause this so that you can access your notebook. So we're starting here today with Chapter 1, which is Basic Geography. So we're in Unit 1, Background Information for Basic Geography. The first thing we talked about in this first unit was maps. And cartography is the art of map making. And it used to be where people would go around and they'd have to draw out the maps. Now we know that we have map making software that creates those maps. So maps, these are a 2D representation of the Earth's surface. So 2D representation of that spherical Earth surface. We have our early map makers, and the Babylonians were the earliest, some of the earliest map makers. Some of the earliest we have that were drawn by the Babylonians date back to 2300 BC. Next was Aristotle. Aristotle was the first to demonstrate that the Earth was spherical. And Eratosthenes is probably the greatest contributions to this idea of geography and map making. Eratosthenes was the first to use the term geography, and geo means earth and graphy means to write, so it truly means to write the earth. He also calculated the Earth's circumference, and he was the first to divide the Earth into 5 different climate zones. So great contributions to this geography. Next, let's talk about map scale. So map scale is the unit on the map representing the distance on the Earth's surface. And map scale is written in 3 major ways. First is using the bar or the graphic. That's when they have that bar and you measure that bar to determine how far it is on Earth's surface. So many maps, if you look at the map, even using Google Maps or Google Earth, you will see that it has a bar or a graphic there, and it'll be like 1 inch measure equals X amount of miles on Earth's surface. Next is that it is truly written statement, so it would be 1 inch on the map equals X amount on Earth's surface, literally written out. And the third way is using a ratio or fraction, which is the same thing, ratio or fraction. When we look at scale, when using at least 2 different types of maps, so you have to have at least 2 maps, you can distinguish between large and small scale. Large versus small scale maps, and again, you need at least 2 maps to determine large and small scale. This is counterintuitive, meaning that when we look at large scale maps have a smaller land area, and they have more detail of that particular land area. Whereas small scale maps, they will show a larger land area with less detail of that land area. So again, large scale is small land area, small scale is larger land area. And please see Chapter 1, Key Issue 1 questions that we completed from class. You'll find the questions on Google Classroom and the answers in your notebook. Please see those 4 examples of large scale versus small scale. Next, when we look at how scale impacts the understanding of data, when you compare multiple maps, we call this the scale of inquiry. Scale at which you question, scale at which you are analyzing the different data. And scale at which you're questioning can give you different perception of the same information. So please see this bell work that we completed during class. It would be on the same notes with Key Issue 3, 28 to 35, about the different types of density, the difference between concentration, pattern, and density. So if you remember, we looked on page 21 in the Purple Book, and we talked about the election results in the year 2000 with Bush versus Gore. And we looked at this as we looked at a map of the winner by state and the winner by county. And we tried to determine which of these two maps, this is again on page 21 in the purple, which of these two maps was a better indication of voting patterns during this election. In your white book, it is the same concept, but the maps are from the 2008 presidential election with President Obama and Senator John McCain. And we determined that the winner by county map was more accurate because it shows who voted for each candidate in each voting district, not as the state as a whole. That the scale at which you question will impact your understanding and accuracy because it's based on the representation of the material. This is a way of manipulating data and manipulating perception. So for example, if we just showed that small scale map by state, this implies that Bush won in a landslide. So we want to give people the impression that Bush won in a landslide, we would use that map. And it is less accurate. Whereas if we wanted to be more accurate, we would use the large scale map on the left by voting district, which more accurately indicates a close race and shows the clustering of voting patterns, which also shows the regional differences in voting pattern. You will see in the map that the west coast of the United States historically votes Democratic in these elections. In the southern part of the states, recently, they have been voting Republican. But if we look at the by county, we will see that there are also patterns within the county, and that's usually urban versus rural. Theoretically, the more urban areas vote more Democratic and the rural more Republican. That's not every time, but in general, we see this. So for purposes of accuracy, the large scale maps are more accurate. They show more detail. Next is this U.S. Land Ordinance of 1785. The purpose of this was so that the United States government in this late 1700s, during major times of settlement in the West, instead of people just going and claiming land for themselves and the government had no way of knowing who owned what, they created this law called the U.S. Land Ordinance of 1785 to divide up the earth's surface into a series of plots and parcels. And they used this township and range system. And what this did, this is why your house sits on a rectangular plot, parcel. That's how it's recorded from the government. So the government could sell that land, record it, and they could tax it so they know exactly where your property ends and somebody else's begins. Next is this idea of map projection. This is projecting from a 3D sphere to a 2D flat map. And when you do that, that creates distortion because you're literally taking a spherical surface, cutting it in half, stretching it out, and putting it up on a flat surface. So there are 4 different ways maps can be distorted. They are distorted by shape, which they can be more, the continents can appear more elongated or more squat. By distance, between 2 points may be increased or decreased. By relative size, the area may appear larger on the map but really be smaller. You see this especially at the poles. You see that in Antarctica and the North Pole look very large on a map, when in reality they're not. That's just because they've been stretched out. Last one is direction. From one place to another can be altered depending upon what type of projection they're using and from where they're projecting. If they're projecting from the poles, if they're projecting from the equator, it will change the way that is depicted. The 2 most common projections you will see are the Robinson projection, which is the one we've been looking at in class. This is the one that represents that they're still spherical. And then the Mercator, which is, the Robinson is the least distorted of all the projections. The Mercator, this is used mostly for navigation. It is a complete rectangle with a grid pattern laid out on top of it to show the latitude and longitude, the absolute distance and direction. So this is especially distorts at the poles because it is truly stretched out into a rectangle. Again, the Robinson is the one we use in class, the one you see most often, and the Mercator, this is the one where you have the grid pattern laid out. Next are the modern geographic tools that geographers use. We have GIS, GPS, and remote sensing. GIS, this is Geographic Information Systems. This is analyzing, storing, and layering of data. What this really means is this is map making software. So this is the software that's built into the computers where if you go on Google and you type in Chick-fil-A and it brings up a map of where Chick-fil-A's are, that map was created instantaneously with GIS, the map making software, and it layers on more information depending upon how much more you want there, like the street map. You want Chick-fil-A, then in relation to Chick-fil-A, do you want to know where the school is? And then in relation to that, do you want to know where McDonald's is? All of that is done with GIS, the layering of data. Next is GPS. This is using satellites to find the absolute location of a person on Earth's surface. And finally is remote sensing. This is capturing and storing data about Earth, acquiring, capturing, and storing it about Earth from a remote device from above. That remote device can be satellites, it can be an airplane, it can be a drone, it can be a balloon. It could be you standing on top of a building and taking the picture of what's been below you once every year for 10 years to see the changes. Remote sensing is how we get pictures of devastation after a hurricane from above. It's also how we get pictures of the degradation of a rainforest from above. It's also how we get pictures of hurricanes from above. They fly that National Weather Service plane into the hurricane and then above it to take a picture of it so we can see how large it is. That's all remote sensing. Next is the 4 ways that geographers identify a location. They do this by toponym, site, situation, and mathematical location. Toponym is just the technical term for the name of a place. So Winter Park, Florida is a toponym. Winter Park High School 9th grade center is a toponym. It's just the name of the place. Site, these are the physical features of a location. It has to be physical, natural features. This would be its climate, its topography, its vegetation, its water systems and access to water. It would be its elevation. It would be its soil quality. So site of Winter Park, we would be hot and humid with lots of lakes and rivers nearby. We have tropical vegetation like palm trees and oak trees. We have good soil quality, so we grow lots of citrus and sugarcane in the area. We have a flat elevation, flat topography, but with some sandy soil. We are at sea level. That would be our site, physical features of a location. Situation is its relative location, so where are you in relation to something else? So Winter Park is east of Orlando. We are in Central Florida. We are west of the Atlantic Ocean. We are also in a wealthy area of Central Florida. That's all situation. Next is mathematical location. This is using absolute location, the point of latitude and longitude, the point at which they cross. So this is its absolute location, it's the exact place on Earth. This is the least used of the 4. You don't go around typically giving people your latitude and longitude digits. When we look at mathematical location, we use parallels, which are the lines of latitude. These are those that are parallel to the equator, so these are the lines that are north and south of the equator. We use meridians, which are the lines of longitude, which those are east and west of the prime meridian. Prime meridian is 0 degree line of longitude, the equator is 0 degree line of latitude. The mathematical location also determines time change and time zones. So for every 15-degree change in longitude, time changes by 1 hour. So for example, we are in the Eastern Standard Time Zone here in Orlando. If we go directly west of us, we will enter the Central Time Zone. That's where Chicago is. They are 1 hour behind, so they are 15 degrees longitude west of us. Then the time zone to the west of them is the Mountain Time Zone. They are 2 hours behind us, so that means they are within the 30-degree line of longitude west of us. And then the West Coast, which is where California is, Washington State, that's the Pacific Time Zone. That is 3 to 4 hours behind us, depending upon the time change during the year. So they are either 45 or 60 degrees longitude to the west of us.